Hello friends, welcome to Gridify. I am Arham Doshi and let's get started. In this video we'll be going to discuss about a secret data structure which is very useful in CP, that is PBDS, and not a lot of people know about it. Okay, so PBDS refers to a set of data structures, and among that one data structure is ordered set. Okay, and PBDS refers to policy based data structure. It is not in standard template library. So standard template library has lot of data structures like set, maps, text, and queues. But this is not in standard template library, so you need to include some headers that will include this PBDS library in your code. Okay, so now what is ordered set? Ordered set is similar to set, in which it has all the functions that is used in set, like insert, delete, lower bound, which means it has all the functions of normal set, but along with that it has some extra functions because of which it is useful. Those two functions are order of key and find by order, like order of key and find by order. So now let's see what they are. So now let's discuss the two functions. First one is order of key. So what this function returns is the number of elements that are strictly less than x. So if this is the set we have with elements 1, 2, 4, 8 and 16, and if we write the function order of key 2, then it will return 1, as there is only one element less than 2. If we write order of key 5, then it would return 3 because there are 3 elements less than 5. The another function is find by order. So it will return an iterator to the number at index x. So if this set were to be an array and it were to be sorted, then what will be at index x? Okay, so let's say we write s dot find by order and we write like 2. Then in the sorted array, let's assume this is an array and it is already sorted. So what will be at an index 2? That is 4. So it will return an iterator to the 4. Iterator is nothing but an pointer that is pointing to the number. So we can access the number at the iterator by using star method. So the answer of this would be 4. If we write something like 1, then it will return an iterator to 2, and like if we access it by star, we will get 2. What if we write the index that is outside greater than the maximum element? Then it would return the pointer to the end, like that is s dot end. This is the pointer that is just outside the just outside the last element of the set. So if we write find by order and let's say 60, then it would return s dot end. This is basically saying that we don't have any index like 60. Okay, so let's move on to the code part. So in coding part, first you need to include some libraries. That is, you just copy paste this 3 lines. It is basically including some important libraries, and the functional is for importing the comparator. Okay, and you have to use the namespace GNU PBDS, and to use the particular data structure, you need to define this data structure using this particular line. And you can name the data structure anything. I have used data set. In this, this is the field which defines the data structure which you want to store in the PBDS, and this is the comparator function of that. Less means less dot int just represent that you want to sort the elements on the increasing order. If you write greater n, it will sort it based on decreasing order, just like that. So let's first insert some elements. I have just defined the data set as that is and let's just first insert some elements, and after that I have inserted few elements like 4 1 8 2 1, and let's just print this element. Okay, so we can see here the content of the set. We It is a set, so it will have unique elements. So even if we insert one more than one time, it will just have only single one. And let's now try to use the functions. First one is order of key. So if we write order of key 2, it will print the elements that is less than 2, and in this we have one element less than 2. Okay, so instead of writing this whole line, I have just defined the short version, the alias of it. That is, we can write FBO and OOK, which will be like short version of find by order and order of key. So I will also define this. So this both are same thing. So we can see here that number of element less than 2 are like 1, less than 3 are like 2, that is 1 and 2, and less than 5 are like 3, that is 1 2 and 4. Now coming to find by order, using this function like s dot find by order 1, we will get what is at the index 1 in the sorted order. Okay, so this will give us what is at the second index, and this is just the alias of find by order. And what if we write the index that is not in the array? So it will just return the iterator equal to s dot end. So we can see that at the first index there is element is 2, that is this. At the second index element is 4, and at third index element is 3, and we don't have any index like 4, so it is giving equal to s dot end. Okay, so the thing is, if you want to implement some another data structure, you can just change it here. Like if you can write pair of int, and you can also change it here, and you can like use now pair in place of it. Okay, so now let's move on to an interesting question. The question is, given an array, you are given a size of a window. You have to iterate through all the sub arrays with length equal to that window, and in that window you have to find the median element. If the size of an array is even, then you have to take the average of both the medians, and otherwise you have to take the median of that element. So let's say the window is like this 2 3 and 4, the median is 3. If the window is like 1 2 3 4, the median is the average of the two elements in the window, that is 2.5. so how can we do this using PBDS? Let's say we have an array this, and the k is equal to 3. For this, what I will do is I will maintain the elements of the window in the sorted set of each window. So at first I will have the elements like this, then like this, then like this, and for each window I will try to find the median element. And from moving from one window to another window, I will just exclude the first element and include the last element. And to find median element, I can just find what element is present at the k by 2th value if it is like odd. Okay, so let's see how I have implemented it. I wanted to use multi-set, so for that I have used the data structure pair of intent, in which I will store the value of the element in first value of pair and its index in the second, and similarly I have used less here. I will first insert k minus 1 elements in the window, and I will maintain the answer to store the answer, and after that I will just insert the last element of the window, that is the new element that is incoming in the window. And if the window size is even, then I will try to find the median of the k by 2 minus 1th index and k by 2th index, and if the window size is odd, I will find the median that is at k by 2 index, and I will just erase the element. I have used lower bound here. If you don't use lower bound, just directly erase, that's also okay, and I will just return the answer. So yeah, if you liked the video, smash that like button, and until next time, goodbye.